Hi guys, maayong adlaw. Welcome to NatzMath TV. So for today's video, my presentation is about addition and subtraction of radicals. I already have a video about simplifying radicals. We will be using our knowledge about simplifying radicals in performing operations with radicals, specifically on addition and subtraction of radicals. So before we proceed to our examples, we have to take note that we can only combine radicals by addition and subtraction only if they are similar. So when can we say that the radicals are similar? Similar radicals are those radicals having the same index and the same radicand. So what are these index and what are these radicand? So for example, you are given the nth root of a. Our n here is what we call the index and our a is what we call the radicand. And of course, this is our radical symbol. So we have to take note that when we add or subtract radicals, we have to see to it that our index here is the same and of course the radicand is the same. If in a radical expression, if there is no index written in a radical symbol, that means that the index is 2. Okay, now let's proceed to our examples. For example, we are given these radicals. 5 square root of 3 plus 7 square root of 3. We have to take note, we evaluate first the index and the radicand. So here, in this example, our index here is 2 since this square root. The index is not written, that means the index is 2. So we have the square root of 3 and another one we have the square root of 3. If we are going to combine these two radicals by addition, so we just simply combine or add the numerical coefficient. In this example, our numerical coefficient is 5 and here our numerical coefficient is 7. So what we need to do is just simply add the numerical coefficient. So 5 plus 7 is 12 and we just simply copy the common radical, which is the square root of 3. Remember, do not add or subtract the radicand. We just simply copy the radicals. What we need to do is just simply perform the operation on the numerical coefficients. 5 and 7 here are what we call the numerical coefficients. So since this is addition, so we just simply add 5 plus 7. So our answer is 12 square root of 3. Let's proceed to another example. This example, you are given 5 the cube root of 10 minus 7 the cube root of 10. So as you have observed, we have here 3 and 3, so the index are the same. And our radicand is 10 and 10, so they are similar. So therefore, we simply subtract the numerical coefficient 5 and 7. That means 5 minus 7 is negative 2. We copy the common radical, which is the cube root of 10. Another example. This time we have here 10 the square root of x plus y plus 7 the square root of x plus y minus 2 the square root of x plus y. So as you have observed with the index, they are the same. We have here 2, 2, and 2. Since there is no index written, so that means our index is 2. And with the radicand, we have x plus y, and x plus y. So basically, our radicals are similar. So what we need to do is to perform the operations with the numerical coefficients. So we have 10 plus 7, we have 17 times the square root of x plus y. Then we copy minus 2 times the square root of x plus y. This time we subtract 17 minus 2, that will give us 15. And we copy the common radicals, which is the square root of x plus y. Okay, let's proceed to another example. For example, we are given these radicals. Square root of 12 minus 2 square root of 32 minus 4 square root of 72. This time, as you have observed, the index are the same. We have here square root, that means 2, 2, and 2. Our index is 2, so meaning there is no problem with the index. They are similar. How about with the radicand? So we have 12, 32, and 72. Basically, as you have observed, they are not similar. They are different. So what we need to do here is that we just simplify these radicands here. Since we can simplify 12 by factoring 12 using one of the factors as perfect square. So we can use 4 times 3. We can rewrite these radicands as 4 times 3, which is 12, and 4 is a perfect square. Then we copy minus 2 then 32 can be written as 16 times 2. 16 times 2 is 32, and 16 is a perfect square. The same happens for 72. We copy minus 4. Then 72 can be written as 36 times 2, which is 72, and 36 is a perfect square. We extract the square root of 4, which is 2, and we place 2 outside the radical, so this becomes 2, which is the square root of 4. So, ari na siya sa gawas. Then what remains in the radical would be the square root of 3, since 3 is not a perfect square. Then the same thing happens for 16. We copy minus 2. Then since 16 is a perfect square and the square root of 16 is 4, so this is 4. We place 4 outside the radical now. So we have what remains in the radical would be the square root of 2. Then we copy minus 4. Then the square root of 36 is 6. So we have here times 6. Then we copy the square root of 2. Now, as you have observed, we have two radicals here which are similar. We have the square root of 2 and square root of 2. And we have here the square root of 3, which is not similar to these two radicals here. So we simplify. We copy 2 square root of 3. Then 2 times 4 is 8. We copy the radical square root of 2. Then 4 times 6 is 24. Then we copy square root of 2. This time, we can combine these two radicals here, the second radical and this third radical, because they are similar. We just simply copy the first radical because this is square root of 3, which is not similar to these two radicals here. So we copy 2 square root of 3, then negative, we perform the operation since they are similar. So negative 8 minus 24 is negative 32, and we copy the common radical, which is the square root of 2. So our final answer is 2 square root of 3 minus 32 square root of 2. Now let's proceed to another example. For example, we are given negative 2 fourth root of 32a plus 3 fourth root of 2a minus fourth root of 162a. So the same concept earlier, since the radicands are not similar, so what we need to do is to factor out 32 in such a way that one of the factors is a perfect fourth root. The same concept with 162. We factor out 162 in such a way that one of the factors will be a perfect fourth root. Since 2 is not factorable anymore, so we just simply copy 2a. So this becomes, we copy negative 2, we copy the fourth root of, we factor out 32, that gives us 16 times 2, or 16 times 2a. 16 times 2a is 32a. Since 16 is a perfect fourth root, 16 also is a perfect square, but 16 is also a perfect fourth root. That's why we use 16. Then the second radical, we just simply copy, as I've said earlier, since 2 is not a perfect fourth root, so we just simply copy 3 times the fourth root of 2a. We copy minus. Then what we did with 162 is just simply factor out in such a way that one of the factors will give us a perfect fourth root. In this case, we can use 81. 81 is a perfect square. At the same time, 81 is a perfect fourth root. So 81 times 2a, that would give us 162a. So if we are going to simplify now, we just simply copy negative 2. This one, we have here negative 2. Now this time, the fourth root of 16 is 2. That's why we have here times 2. Why? Because when we multiply 2 4 times, since this is fourth root, so we have 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's why our fourth root of 16 is 2. So what remains in the radical now will be the fourth root of 2a. So this one, since 2a is not a perfect fourth root and this is not factorable anymore. So we copy add. Then we copy the same, the second radical, 3 times the fourth root of 2a. Then the fourth root of 81 is 3. Because when we multiply 3 4 times, that is 3 times 3 is 9. Then 9 times 3 is 27. And 27 times 3 is 81. So therefore, the fourth root of 81 is 3. That's why we have here the 3. Then we copy the fourth root of 2a. As I've said, 2a is already not factorable. So we just simply copy 2a. This time, if we are going to evaluate the index, we have here 4, 4, and 4, so they are similar. And the radicand, we have here 2a, 2a, and 2a. So therefore, the radicals are similar, so we can just simply perform the operations with a numerical coefficient. But before that, as you have observed, we have here 3 times the fourth root of 2a minus 3 times the fourth root of 2a. As you have observed, they are the same. We have here 3 and 3, then fourth root of 2a, fourth root of 2a. So what we need to do here, since they are the same, we can just simply cancel out. Meaning this is 0 because 3 minus 3 is 0 and any number multiplied to 0 is 0. So everything is 0. Then we multiply negative 2 times 2, that would give us negative 4. Then we copy the radical fourth root of 2a. So this is our final answer. Next example. How about if we are given 2 square root of 20 minus the square root of 20 plus 3 square root of 20 minus 2 square root of 45. As you can see, we have here 20, 20, and 20, and they are all square roots. So as you have observed, they are similar, unlike with the last radical, which is square root of 45. So what we need to do here is that since 20 is factorable, though we can perform directly the operations here, but since 20 is factorable, so we just simply factor out first 20 in such a way that one of the factors will be a perfect square. So we will have, we copy 2, then 20 can be written as 4 times 5, which is 20, and 4 is a perfect square. The same happens to the second radical and of course to the third radical. And with the fourth radical, so we have 45. We factor out 45, that would give us 9 times 5, and 5 and 9 is a perfect square. Then we extract the square roots. We have here 2. We copy the 2. The square root of 4 is 2. So this is now our 2. Then what remains in the radical would be the square root of 5. Since 5 is not a perfect square and it is not factorable anymore. Then, with the second radical, we copy minus. The square root of 4 is of course 2. Then, what remains in the radical is of course the same, square root of 5. With the third radical, we copy plus 3. We have here plus 3. Then the square root of 4 is 2. So we have here 2. Then the square root of 5. Minus, we copy 2. The square root of 9 is of course 3. Then we copy the radical square root of 5. Now, if we are going to evaluate the radicals here, we have square root of 5, square root of 5, square root of 5, and square root of 5. So therefore, they are similar. So we can combine everything. But before that, we perform first the multiplication here. So this is 2 times 2 is 4. Copy the radical square root of 5. We copy 2 minus 2 square root of 5 plus 3 times 2 is 6. Copy square root of 5. 2 times 3 is also 6, so we copy minus 6 square root of 5. The same concept earlier, we have here 6 square root of 5 minus 6 square root of 5, so we can just simply cancel out because everything is 0, so this is 0. So we have here 4 square root of 5 minus 2 square root of 5, so 4 minus 2 is 2, then we copy the common radical square root of 5. Again, do not add or subtract the radicand. What we need to combine here for addition and subtraction of radicals are the numerical coefficient, but see to it that the radicals are similar. Okay, so that's it. I hope you have learned something from this video. So before I go, please do not forget to subscribe, like, and share to your friends, especially those who are incoming grade 11 students and of course for the junior high school students. And this time, thank you and God bless.